Hey, this is Sanyam Bhutani, and you're listening to Chai Time Data Science, a podcast for data science enthusiasts where I interview practitioners, researchers, and Kagglers about their journey, experience, and talk all things about data science. Hello and welcome to another episode of the Chai Time Data Science Show. In this episode, I interview Bart, who is a computer science undergrad at the University of Waterloo. Bart has just finished his software engineering internship at Google. And in this interview, we talk all about his internship where he worked on Swift for TensorFlow and contributed to the project. We talk all about his experience interning at Google, Swift for TensorFlow, and OpenSpiel. This is a part of the Swift for TensorFlow release series, with the next episode being an interview with Dr. Mark Langto, a research scientist at DeepMind, where we, of course, talk even more about Swift for TensorFlow, research at DeepMind, and, of course, AlphaGo. So do subscribe or stay tuned if you'd like to check that episode out. For now, here's my interview with Bart. Please enjoy the show. Hello, Bart. Thank you so much for joining me on the podcast series.
Yeah, no worries. Pleasure to be here.
A pleasure to have you on the show. So you just finished your internship at Google, which was all about Swift for TensorFlow, which we'll just talk about. You've also worked as a data science intern at a healthcare startup. You mentioned this during our offline conversations. Could you tell us how did you get started with machine learning or data science, broadly speaking?
Sure. I can even go a bit farther back where when I entered university, I think I'll discuss this a little bit later, but with our university, we got the opportunity to do a lot of internships. Mm-hmm. And my goal with all my internships were I wanted to try something new every term. First, I tried full stack, and then I tried iOS as my second internship. And then I really kind of saw my friends and others kind of get into data science, and I kind of saw the buzz behind data science, and I was just thinking to myself, like, let me try this for a semester. Let's just see how it is. And because I did my iOS internship at the health startup, I went back to them and being like, is there an opportunity for me to try data science? And they said, yeah. And that's really got into data science. It was just kind of the already existing connection I had with a previous employer and just trying it out myself and seeing how it is. I did previously also do some like little side projects and like Udacity courses on myself. That was really my first kind of like professional experience.
Okay. Got it. So before we talk about Swift for TensorFlow, could you tell us so you have an interesting setup at your university and program. Could you tell us, the listeners, more about it and what internships requirements do you have? Because you mentioned this and it's pretty interesting to me at least.
Sure, yeah. So I go to the University of Waterloo in Canada. And with the University of Waterloo, I'm in the computer science co-op program. Okay. And our university has a really intense co-op program, co-op being just like internships, where we do 6 4-month internships in our undergrads. Additionally, our undergrad is a
4-year course, right?
So it's a 5-year undergrad because of the 6 internships.
Okay.
So in total, like we do 2 years of internships, and how it works is after the first year, it's like you do 4 months of school, then 4 months of co-op, 4 months of school, 4 months of co-op, school co-op, school co-op, all the way until you graduate. We have no summers off. Okay. Sometimes it sucks because like I finish my internship on a Friday, I fly out on a Saturday, I stay home on Sunday, and need to move in back to school on Monday because classes start Tuesday. Sometimes I have no breaks.
Interesting. But I'm sure the payoff's totally worth it, at least maybe after you graduate.
Yeah, definitely.
To help us set the stage for Swift for TensorFlow, could you tell us how did you end up applying to Google and why did you end up choosing the Swift for TensorFlow project that you worked
on? So those who are like unfamiliar with the Google intern hiring process, you apply to Google like as a general intern. You don't interview with a specific team. You interview for like Google.
Okay.
And it consists of like two interviews, like over the phone, like 45 minutes each, which are just the basic data structures algorithms. And then you get to know whether you pass that stage. And
Okay.
I passed that stage in July 2018. And I had to get an internship for the fall, just because of my co-op program. I had to get an internship for the fall.
Mhm.
And I did not have enough time to find a team, as after you get accepted to Google, you need to go through host matching. And
Okay.
host matching can take a while, and I didn't have enough time to do it for the fall. So then my recruiter was like, let's just move this to the next term so you can find an internship for the summer.
Mhm.
So while I was doing my data science internship in San Francisco, I was going through the host matching process.
Okay.
And the first person to reach out to me was my host, Richard, from
Mhm.
Swift For Tensorflow. And in total, I had two interviews. The second one I wasn't too interested in. It was like Objective-C iOS.
I see.
And I didn't really want to go back to iOS because I already did that before. I want to try something new.
Mhm.
And what Richard was looking for was someone who had iOS experience, who knew Swift,
Got
and
it.
was also interested in data science. And through my resume, he saw that I had both. And we talked. And one of the big things I think was a convincing point was that I wasn't really, during my data science internship, I didn't really gain a huge, I didn't completely enjoy pure data science, like with
I
creating the
see.
models, data pipelining, all
Mhm.
the SQL.
Yeah.
I really liked and was trying to look for a position which has more like the software engineering, like creating the frameworks, things of that nature. And I kind of told them that I was like, I don't like pure data science, but I still want to be involved in this field. And that was kind of a perfect match for the project
Yeah.
because that's exactly what they're doing. They're kind of creating these tools for machine learning researchers
Yeah.
instead. And that's how we kind of found a match for that. That's
Got
how I
it.
kind of got the internship.
To linger on to that point for a little longer, could you tell us how did you prepare for because I know the interviews are difficult and the questions might be
Yeah.
under NDA. So generally speaking, how did you prepare for especially the data science and algo questions?
So with it was like the data structure and algorithm
Data
questions.
structure and algo, sorry.
So with the way, so it was really dependent. But for when I was interviewing for the like host matching, like finding the team,
Mhm.
it was not technical at all. It was just like me and
Okay.
potential hosts talking about like, oh, this is the project. Are you interested in this? Do you know this? Do
So
you
it
want to
was
work on
more of a
this?
conversation rather than an
Yeah.
got it.
However, the previous interviews, the one which is like that initial screening with the two interviews, that's pure data structures and algorithms. And what I've always practiced was so a lot of my friends use like the typical lead code and practice lead code. What I do is I have this book called Elements of Programming Interviews,
Okay.
specifically the Python version. And I like it how it's basically, it sets up all these units. Like first it goes into string manipulation questions and arrays, binary search, recursion, dynamic programming. And I generally go through the questions and read the solutions and understand the solutions, as it
Okay.
very well sets up the solutions in the way that you actually want to answer in an interview. Like, for example, it goes into the naive approach, the brute force approach, discussing how it would work, why isn't it efficient, and then it kind of goes further, like, okay, how can we improve on this and create
Interesting.
the better final solution, which is the best. And that's exactly what interviewers look for
Yeah.
in interview. Not so much to get the right answer, but can you explain how you got there? And it really kind of sets up well the solutions to explain how
For
to
sure.
get there.
So I don't remember all of these topics. Do you think this is also good beginner recommendation in case they're new to these terms? The book?
Uh, I think I actually went through that book even before I took some of the courses that even taught me in university, and
Okay.
it definitely doesn't tell, like, it's definitely not like heavy in like the theory, but it nicely
Mhm.
kind of shows you like how to implement it, and even the code is really easy to learn. Like if you're not familiar with dynamic programming, through the book you might be able to kind of really learn it. But also you can very much kind of search up on like Geeks for Geeks, which also has a bunch of explanations of
Yeah.
like what dynamic programming is and things like that. So I
Got
think
it.
it's a very good beginner book. I got it in my first year as well.
Okay. I'll make sure to have it linked in the description in case anyone wants to check it out. Now, coming back to your internship, before we talk about what you worked on, could you help me set the stage by telling us what Swift for TensorFlow is all about and what promise does it hold in your opinion?
Sure. So the way I like to think of like Swift for TensorFlow is like I think what the team manager Brennan always kind of says, we want to kind of create an infinitely hackable platform
Yeah.
in the sense of the way the current data science machine learning ecosystem is you have this very like thin Python layer, and then just a bunch of C++ code underneath. And C++ can be very complicated to write. And even through my internship, talking to people who write C++ code at Google, it's hard to find a person who really enjoys writing C++ code.
That's really interesting.
And what's Swift trying to kind of come and do is you're going to write the top layer in Swift and every layer underneath in Swift. It's entirely in Swift. So if you, for example, wanted to write your own layer or you wanted to look at the implementation, you just simply like command click and go to definition, and it automatically puts you to the definition of where the convolutional layer is defined. And you can exactly look through it, and you don't need to learn a new language and understand any more context, because it's hard to jump from the Python code to C++ because then you need to get familiar with the C++ code. But with Swift, it's all in one. And yeah, and additionally, Swift has some benefits of being just as fast as C++. It's statically typed, unlike Python, so it's all type checked. So they're not going to have like some error 3 hours in saying you're past a string and they're trying to add a string and an integer 3 hours in the training or something like that.
Yeah.
Additionally, one of the goals that I think I was working on was making the first differentiable programming language. So being able to just take derivatives of any arbitrary function.
Got it. But one of the things that I sort of am concerned about is C++. It's maybe okay for researchers, but really for the practitioners who don't have a programming background, they're comfortable with Python right now. Do you think Swift would be easy for them to pick up, or that might be sort of a challenge for them?
So I think the people who are most excited about, I think, the Swift For TensorFlow project, I think it's like two groups: iOS developers and some of the people who are implementing like the C++ code. The reason why is, firstly, for iOS developers, the way you write models for iOS apps isn't very smooth, in that you still have to write your Python models, train your Python models, export it, and then basically just dump it into your iOS application. And with TensorFlow, you can write the entire model in Swift, put it on your iOS app, and you can do on-device training and all that. Similarly, C++ developers are excited because it's no more C++. But with the Python, I think there's going to be some trouble, mainly because it's not as like easy to read, mainly just because it's statically typed. However, if you ignore like this, the fact that it has types, it can be just as easy as writing Python code. Additionally, because Swift is known as primarily iOS, macOS programming language, and even though it's still general purpose and it works on Windows, even works on Android.
I didn't know that. Okay.
It works on Android as well. There's someone open source contributor supporting that. The problem is that there's not a big, I guess, data science community behind it, and as such, some of the libraries that exist in Python, like NumPy, Matplotlib, sklearn, Pandas, doesn't exist yet in Swift. And as such, it's hard for, I think, right now, Python people to move over to Swift, just because the community's not there. However, over time, I think we can really build that community, especially once we get this differentiable programming feature into the Swift programming language.
Also, given the promise, do you envision that developing the Pandas and NumPy analog would be easy compared to the efforts that it took for Python? Once Swift reaches that stage, of course.
I'm not too sure. But like I think the fact that I'm not sure about Pandas, but I know NumPy for sure is implemented all in like C. It could be easier because, again, like with Swift, it could be just as fast as C or your C++ code. It could be much faster to implement. Of course, though, those libraries have been worked on for many years, so it could take some time to increase, like really bring it up to date. So I really think the C++ and the Swift developers will use it. Will take some time to really convince those Python programmers to move over.
Got it. Now, coming to the parts of development that you were involved, could you speak to that, and what all aspects of the project were you involved in while you were interning at Google?
Sure. So I was working on like one of the sub teams where we were basically making Swift a virtual programming language. So adding automatic differentiation into the compiler. And for those kind of unfamiliar with like automatic differentiation, you can define your own function, let's say foo, which takes in a float, outputs a float, and all it does is, let's say, returns x times x. You ask for the gradient, you ask for the derivative, and it will generate a function at compile time, which is the derivative function, or it will be the function that gives you the gradient.
Yep.
So I was working on a couple aspects of that because when I was coming to my internship, I didn't really know compilers and also how to create how to create libraries. As I really came from a background of being like kind of the consumer of libraries and never even working on compilers. I started off working on making standard library types differentiable. So in Swift, there's a type called SIMD, and which is kind of like this fast vector that can execute really quickly on processors.
Okay.
So I made that differentiable. I was also making complex numbers differentiable because we want to investigate how do complex numbers behave in our system, because there's a bit of intricacies to whether a complex number or complex function can be differentiated, specifically regarding Cauchy-Riemann equations.
Okay.
And then I kind of went into the compiler work. And one of the things that we want to do with our kind of final system is have functions defined as differentials. So like if you have a function x times y, the differential is dx times y plus dy times x.
Right.
Because in our implementation, you define all these primitive derivatives. But the thing is that that's kind of like this forward mode differentiation. However, for example, in backpropagation with neural networks, you use reverse mode differentiation, where basically you have the scalar loss, and you're taking the derivative kind of backwards.
Yep.
Because with forward mode, you can think of if you have a function x, y, z, and it outputs some a, you're taking in forward mode the derivative with respect to x, the derivative with respect to y, the derivative with respect to z. But reverse mode, you just take the derivative with respect to a, your output, and in one pass, it gives you the reverse. So, but the thing is, reverse can be a bit hard to understand. So what we implement are these things called the transposes, which are like the transposable functions. To kind of explain what kind of transposable functions are, is they're basically like linear functions. If you have a function, let's say y equals mx plus b, the derivative everywhere is m. It's m at x equals 1,000,000, x equals 5, everywhere is just m. And that's a linear function, and that's a transposable function. But when you have something like the quadratic function, y equals x squared, the derivative is 2x, and the derivative is not the same everywhere. At x equals -5, it's different than what it is at +5. And that's not a transposable function, because it depends on that original input. And what we can do is, because the derivative is basically your tangent of, let's say, if you have x squared, it's just the tangent line at some point. This is a linear line, and what we can do is we take that function, which is linear, because it's just a straight line tangent, we can reverse or transpose it, and by transposing all these linear functions, we can get the reverse mode. And through reverse mode, we get a really efficient backpropagation for your neural networks. So what I was adding was I was adding the type checking for whether a function can be marked as transposable with respect to all these different variables, and because the function signatures can change. Like if you have a function x which takes in a float, outputs a float, and just does x plus y, let's say. The derivative with respect to both, the transpose with respect to both inputs is a function which takes one input and two outputs. With respect to just one of them, it just takes two inputs and one output still, if it's with respect to just a single input. So it's doing some of the type checking there. And then finally, I was working on implementing the forward mode AD, because at that point, we only had reverse mode AD, mainly because we wanted that efficient gradient calculations for the backpropagation via the neural network models. But we want forward mode because it's just more intuitive and easier to understand for users and people who would use Swift in other areas other than deep learning. They wanted to use it in like ray tracing or something like that. So I was implementing the forward mode, which basically is looking at the original program and spitting out the differential. I have, I think I'll probably send you this after. I have a couple of, I think, resources to anyone interested in how I implemented this. I did, I think, one of the open design meetings, I presented the implementation details of how forward mode works. And additionally, in there, I explained as well how control flow works, as control flow can be a bit difficult. And that was really my final cut project, was just the forward mode stuff. And yeah, that's
Okay.
my internship. There's still a lot more work to do on the project.
I'm sure about that. Quick shout out to the Swift for TensorFlow team who's been kind enough to run these open design meetings, as you mentioned. So literally anyone of the listeners, if you want, you can jump on the design meetings and even talk to Chris Latner himself, of course, if you have the right ideas. So please do attend those in case you're interested.
Yeah, we have also a mailing list that people can join, and in there we kind of announce what we're doing during those open design meetings. And as well, in that mailing list, you can ask any questions you have about any bugs you're experiencing or any more information about the project or how to contribute as well.
I'll make sure to have it linked in the description for anyone who's interested. In hindsight, you talked about all these concepts, which some of these would be easy given the math background you might be undergoing at your university. But in hindsight, how difficult was it to understand how this is being implemented in the background and then work on it after that?
It definitely was very difficult. It was like I took 3 calculus courses prior to that internship, and when I joined the internship, sure, it's all about derivatives, but automatic differentiation is very different, especially the reverse mode. Like it took me a couple of weeks to figure out exactly how reverse mode works. Like, what does it mean? What is the reverse the reverse derivative of a function? So definitely took a lot of just looking at the existing functions, talking to my hosts, other mentors, other people on the team. But after that, I really got a hang of it. And additionally, the compiler details were really, really difficult, but it was definitely like I really needed the help of kind of like with my hosts and my mentors to really kind of understand. It's a very tough kind of thing to get into as a new open source contributor. As a new open source contributor, it's very difficult to kind of get into the compiler, especially with the AD stuff. Right. However, there's definitely, I think, a lot of great opportunities, for example, in some of our other parts, like creating new models, making existing stuff differentiable, and things like that. It's still more on the Swift level, not so much the compiler level. Okay. As the compiler level can be very tricky for people. Like I think we did have an open source contributor, Anthony, who's a PhD student at CMU. But with him, he really has experience working on compilers beforehand.
Got it. Now, coming to the experience of interning at Google, like you mentioned, your host, I'm sure would have been helpful while you were picking these topics up. Could you also speak to the experience in general, and what did a day in your life look like while you were working there as, I think they call it a noogler? I'm not too sure.
Yeah, noogler. Yeah, so yeah, I think for any new full-timer, they call them like nooglers.
Okay.
In terms of day in life, I think generally speaking, one thing I really liked about my internship was the lack of meetings. There's a lot fewer meetings than I was expecting, or at least I had during my previous internships. Okay. So during the day, I had a lot of time to work, and generally what I did was I lived nearby, so I either took the bus to work that Google provided, or I also had an electric skateboard that I rode to work. Just had the breakfast, and then boosted board. Yeah, so a boosted board. Really nice. And then just had breakfast, sometimes by myself, sometimes someone else, and then just generally, depending if there's no meetings or meetings, I work till like lunch, and then with my team or some people, I grab lunch, and then we kind of either sit outside or sit at the common table that's in our building with a variety of people. Then just back to work, and then I think around like 6 or something, we went out for dinner with some people, even from some other teams. Like I went a lot out for lunch with someone called Mike Burrows, and he was really fun to go out for lunch. He has a lot of great stories.
One thing that I really envy from this point of yours is you don't even mention the lunch at Google. So this is derived from the point when I interviewed for the AI residency, and you don't even recognize that the lunch is so amazing at Google. So that's something I really envy.
Yeah, it was. I think I was going to kind of get used to it, even like because like it's kind of like a lot of those companies in the Bay Area, kind of like if you don't provide lunch or something, you're not like the Bay Area company. So even like with my previous internships, I had lunch provided as well.
Makes sense, but still, Google wasn't the best of it compared to others.
The food.
Yep.
One thing that's generally kind of people say is the Google complex, like the Googleplex, which is where I was working, has not the best food. For example, when I went to like DeepMind in England, they had really, really, really good food over there. It was much better than
Okay.
what they had like on Googleplex campus.
Interesting. You also mentioned, and I also found this image on Twitter. I'll try to Photoshop it into the video after I edit it. But you got to meet Jeff Dean and Geoffrey Hinton himself. Could you tell us more about that? And can you confirm or deny if Jeff Dean is an AGI or not?
In terms of AGI, it's kind of hard to say because it's got the Turing tests, right? So if he is an AGI, then how am I supposed to know? He
Yeah.
must be a really good AGI.
Okay.
But in terms of background, so this was during my first week of my internship. Still, like, orientation was going on and everything. And at the time, I was at my desk, I think just setting up my computer, just setting up everything. And I think my mentor was like, oh, there's a celebration for Jeffrey Hinton for his Turing Award. Let's go there and just check it out and see what's going on. And I went there with everyone and kind of saw like Jeff Dean just talking about and kind of celebrating everything that Jeffrey has accomplished. And there was a bit of cake. And then I was like, okay, this is nice. Take a couple pictures. And then kind of went back to my desk.
Okay.
But then after sitting at my desk for like a minute, I was like, no, I gotta go back there and somehow get a picture with them. So I went back there and then I was looking around and I saw Jeffrey Hinton, Jeff Dean, Sergey Brin, and then Mike Burrows all standing in circles. I was like, okay, let me go talk to them for a little bit and see if I get a picture with them. And
Perfect moment.
yeah, it was perfect mode, just right time. All of them were just there together.
Got it. So you also mentioned you got to visit the DeepMind office. Could you tell us more about the visit and maybe how was the office experience in general?
Sure. So I think in July, my team and I went to DeepMind for a little trip, and there was like some stuff we worked on. Not everything I could talk about, but like one of the things I could definitely talk about is what was released end of August called OpenSpiel. I'll talk about OpenSpiel a little bit after.
Sure.
And that was some of the stuff my team got to work on with me because of just the internship kind of timeline. I was very much focused on my project and getting forward mode 80 implemented.
Okay.
In terms of like, I guess the office experience, I really like Google's England office. I really like England and London, especially. I much prefer London, England than like San Francisco or New York or Toronto. It's definitely my favorite city.
Okay.
What else? Got to talk also like a bunch of like people, some engineers on like who made AlphaGo. And then also I saw like the room with kind of like the AlphaStar stuff going on.
Interesting.
I also got to talk to some like the CTO, Dan Belov. It was a lot of fun, really getting to talk to and know people, and also even talk to some existing PhD interns, because I was really interested in like determining whether the PhD is right for me. So I kind of really talked to a lot of them and being like, should I do a kind of like a PhD? Is this the right thing for me?
Okay.
Yeah.
Did you get to play with the bot as well? So Go or chess?
Oh, no.
Okay. And can you confirm or deny if researchers at DeepMind are from completely another dimension? Can they just read equations and turn that into code in the back of their head?
Everyone's very much, even like with Google and like talking to Chris and everyone, even like just Google Brain, everyone's just very down to earth and very much just very open to talking to you. And they're not like, it doesn't feel like everyone's kind of above you of sorts. Everyone feels just like very normal of sorts.
Okay.
Yeah.
So to talk more about OpenSpiel, could you tell us what that project was all about? And I think it was also presented in an open design meeting, so I'll have that linked in the description.
Yeah, it was presented there as well. So what it is it's kind of like OpenAI's Gym, in that it's a reinforcement learning environment. However, there's a lot more, I guess, a variety of environments. They're not just kind of like these Atari and games, these like perfect information games. There's a lot of these like imperfect information games, like poker, Ludo poker, even other kind of board games, or like tic-tac-toe, things like that. It's all these different types of games to give to researchers in both reinforcement learning, but also like game theory. Because with reinforcement learning doesn't always work, for example, in imperfect information games. So it's great for researchers kind of looking at how do we kind of handle and solve these imperfect information games. And also, what we kind of did was some of these existing algorithms that the DeepMind team has implemented in Python, we kind of ported over to Swift. So I think we had like tic-tac-toe, Coon poker, Leduc poker, Texas Hold'em, and also a couple algorithms like exploitability descent, which is a really good algorithm which kind of like is based on game theory, where it tries to emulate the Nash equilibrium, and it's really good in these imperfect information games like poker.
Okay.
And there's also a lot of work to be done porting over some stuff to Swift for if anyone's interested.
For sure. I also want to drop a quick plug. So I actually interviewed Dr. Mark Langto, who's also on the OpenSpiel team and is a contributor to AlphaGo. I think that episode will be out after your episode goes up. So for the listeners, do stay tuned for that in case you're interested. Now, coming back to the internship, if we could maybe zoom out a bit and if you could talk about how's the experience in general while working with the amazing engineers and researchers at Google, any mindsets or personality takeaway that you might have had from just working with them?
Sure. So one thing is that like Google's a really big company, so I think like every intern's experience is different. So like some people have a much different experience than I did. Like I think with my experience, it was very unique, and the places I got to go, people I got to talk to, the work I got to do. And with it, I think the biggest thing I got out of it was, even though I'm kind of young and an intern, don't be afraid to really make an opinion and really kind of try and make an impact on the project. In that, try working on these these new projects that are coming out, and see if you can like really influence that project and really work with some of the developers as an intern to steer it in the right direction and really give your input. Don't be afraid to just criticize what's kind of going on and be like, I don't think this is the right approach. We should try something different. That was the biggest thing I think I got out of it, was really making my own opinion and acting on it.
Now, when you were working with the team, you were already familiar with Swift, but for anyone who recognizes the future of Swift and is maybe excited to jump on board with the contributions, do you have any favorite go-to resources for beginners who just want to get started with Swift specifically?
I forget the name of the book. There's definitely a lot of resources out there, like in terms of like if you're kind of more of a reader, I think there's like a Ray Wenderlich. Which really kind of goes into like a really intro into Swift and how Swift is and some of the syntax. For those kind of more just kind of curious, like just the overview, we ported over I think some tutorial which kind of goes into how do arrays work and things like that as a Colab tutorial on our GitHub, our TensorFlow Swift GitHub.
Got it. Also, it's again, I believe, an open area of contribution in case you'd like to create more resources. Like Python has this amazing wide variety of resources. So once you pick these up, maybe come back to the community and give more resources if you like.
Yeah.
So my final question to you would be, what advice do you have for maybe freshman Bart or someone who's just starting out with open source contributions and someday wants to contribute to Swift for TensorFlow?
Sure. So I think like for contributing to Swift for TensorFlow, I think the biggest thing, like the best areas kind of to do it is take a look at some of the existing starter bugs, either on Jira or the issues tab on some of our repos. Like we have, if you, for example, are more interested in the APIs, like how is convolution implemented, and maybe you want to add another type of layer, you can look into like the Swift APIs repo. One thing is if you already have an existing background with deep learning and want to, let's say, implement a model in Swift, what we are doing is if you implement a model in Swift, like a new model, and it works and everything's great, you can bring it into the Swift models repo and really kind of bring these existing, bring it to like our model garden and have these examples written in Swift that people can use. So there's kind of like a variety of areas. Like if you're interested in creating the models, you can create your own model in Swift, bring it here. If you're interested more in the APIs, and looking at like the Swift APIs is good as well.
Got it. All right. This has been an amazing conversation. Before we end the call, what would be the best platforms to follow you and follow your work?
I think my best will be my Twitter, which is all lowercase BART_CHR.
Okay. Cool. I'll also have it linked in the description in case you all want to check it out. Thank you so much, Bart, for joining me on the show and talking all about Swift for TensorFlow.
It was great. Good talk to you.
Likewise, thanks again for joining me. Thank you so much for listening to this episode. If you enjoyed the show, please be sure to give it a review or feel free to shoot me a message. You can find all of the social media links in the description. If you like the show, please subscribe and tune in each week to Chai Time Data Science.